Hello everybody. So in this module we're going to start moving into looking at how we're going to begin describing data. In the last module we talked about some basic stuff for gathering or basic ideas of what statistics is and what statistics are. And then we looked at some Excel work on how to organize data. Here we're going to start using the data to begin describing it, okay? And so in this module, this is going to be a relatively short module, we're going to look at measures of central tendency. So our goals for this module are to compute the mean, determine the median and the mode for a given set of numbers, describe the common characteristics of the mean, median, and mode, locate the relative positions of the mean, median, and mode on a skewed frequency distribution, determine an appropriate measure of central tendency for data scaled on the nominal, on an ordinal, on an interval, and on ratio levels, and then finally explain why the mean is influenced by extreme values, while the median is relatively unaffected by extreme values. So with that, let us begin by some general questions, okay? So how do we describe something when we have large numbers? For example, how would you describe the typical grade in your class? Okay, so think about these questions. How would you describe the typical ACT score at your school? And how would you describe the typical teacher at your school? So these are all different things that we can use to describe, or different questions where we want to give a general description of numbers. So the answer to all these is what we talk about being average. What does average mean? Okay, for example, we could say the average score in my class is a B. The average ACT at my school is 21.2. Or the average teacher in my school has 12 years experience. Okay, all of these deal with what we call central tendency, but there are more than one way that we use the term average in statistics. Okay, and we're going to look at three ways to deal with average. For example, when we say that the average teacher has 12 years experience, that could mean that every teacher in the school has been there for 12 years. It could mean that we have a couple of teachers who have been there for 40 years and a lot who've been there for 8. It could mean that we have a lot of teachers who've been there for 20 years and a lot of teachers who just started. Okay, so that really doesn't completely give us an idea of the teachers, how we can describe them, but it's a start. Okay, and so it's one way that we describe average. So what we're going to look at are three ways that we talk about average in statistics, and this is the mean, median, and mode. And many, if not most, or all of you have used mean, median, and mode in your work previous to this. So this will be a good review for you, and it does overlap a little bit with Module 1, so it's no stress there that there's an overlap. So let us start by taking the most common thing, and that is the mean. So here we have our mean, and this is what we generally refer to as average. This is the most common measure of central tendency. And keep in mind, what we mean when we say central tendency is where, how much is everybody the same? How close are they to being the same? That's the measure of central tendency. So let's say you gave a test, and these are your scores. We have 10 students. You have a 95, 100, and 90, and 80, 55, and 80, 100, 40, 75, and an 80. Your district has determined you must teach to mastery, and his defined mastery is 80% or higher. Did your class as a whole achieve mastery? Obviously, to get the mean, you simply add the scores together. divide by the total number, and that gives you the mean. This is the arithmetic mean, or the average as we most commonly call it. We can see that 7 students in our data, if we were to look at our data, 7 students scored at 80 or higher, but 3 students scored below our mastery. Our mean for the class comes out to 79.5. So as a class, as a whole, our class did not master the objectives being measured. Okay? So we talked about in the first module what we do with data. We organize, summarize, analyze, and interpret. So at this point, we have done an organization, a summary, a basic analyzation here, and we've gotten down to our mean is 79.5. At this point, you would interpret this. And so what does this mean for you as the teacher, that your class mean was 79.5? Okay, so you might decide that you're going to target those 3 students. You barely made mastery. If mastery is 80%, you're slightly below that. But even if you round it up, you barely made mastery, so is that good enough for you? Okay, so that's how you would interpret it. The so what of it would tell us what we're going to do. So at this point, I want to introduce you to what we call notation. And you will see this throughout the course as we go, especially when we get into analysis and formula that we will use. We use notation in statistics to describe what it is that we are doing. You will see this in various formula throughout the course. And so some of the basics I want to give you. And as we go through this, we will refer back to these basics. So this is a very common expression in statistics. Okay, so I want to point out to you what we have here. This is a capital sigma, a Greek letter sigma. And when we use the capital letter, it means sum. We're going to add up everything. So what are we going to add in this summation? We are going to add in numbers. This is the total number in our sample. We are going to start with the first term, number 1. So we're going to add up the x variable, all the ith terms. Okay, so here this is equal to x sub 1, is how we read that, plus x sub 2, plus x sub 3, plus x sub 4, until we get to our nth term, or our final term. So in our testing, we just had 10 tests. So this would be a 10 up here, and this would be the sum of our 10 terms. Okay, so the sum of x to the ith term equals x sub 1 plus x sub 2 plus x sub n, and n here is 10. Okay, these are the ith terms, and we're going up to 10. So our formula for mean then, for this is our what we most commonly refer to as average. Our formula for the mean looks like this. So this is important. I want you to recognize that we take the x with a line over it. And in statistics, we call this x bar. So x bar equals the sum of all our x terms divided by the capital N, the number that we have within our sample. Okay. Now we're going to see that this may change later to a Greek mu. We'll talk about that, but for now I'm just wanting to introduce you to these terms and the idea that we're going to use these formula to describe what we're doing. Okay, so x bar equals the sum of x divided by n. That's the formula for our mean. So this I know you know how to do. This is technically how it's done. Okay, so let's look at another way to determine average. Another way that we determine average is we look at the median. So to get a better idea of how scores are distributed, we can look at the median. This is a listing of scores in ascending or descending order and finding the middle score. If the n is even, then we simply take the two middle scores and divide by 2. If the n is odd, take the middle number as the median. So here are our scores from ascending to descending order. And we can see that our two middle scores here were 80, so we know that the median is 80, but technically we would add them together and divide by 2. So if we were to look at our median score, then if our target is 80% mastery as a whole, maybe a teacher who's a little bit unethical would say, I had 80% mastery. And the principal says, well, how can you do that? Your average score is 79.5. That teacher could say, well, I took the median score as another way of expressing average. And so my median score was 80, so every student mastered it and we can move forward, okay? It's just an example of how you can use different data and how it might display slightly different. And we're going to see a little bit more extremes here in a minute. These are pretty basic, straightforward numbers. So the last way we're going to look at expressing average is through the mode. The mode is the number that appears the most in a set of data. In our list of scores, the mode is 80. So when we look at our scores, we see that 80 appears 3 times. So our mode is simply 80. If there had been 3 100s in our score, then the distribution would have been what we call bimodal, or 2 modes, with our modes as 100 and 80. Okay? So, with that, now let's talk about the characteristics of the mean, median, and mode, and what these mean and why we would use the different ways to describe average. Remember again, all of these describe average, so from now on we will try to avoid simply saying average and we will use the correct term that we're using most commonly, the mean. So the mean, median, and mode are not always identical. Think of the curve. This was the histograms we looked at in the last module. If we were to make them into a curve, they may look like this at the bottom. This is a typical bell curve here, where we see average is right in the middle. And so on this bell curve, we're considering that our mean, median, and mode are all the same. Okay? And this is what our hypothetical 10-student test score would look like pretty much. And this is very symmetrical. Everything's equal. If you were to fold it in half, it would be equal on each side. But not all curves, when we plot the data, are exactly symmetrical. Okay? So up here we can see, this is an example of GPA scores by ethnicity. And so here we have black students with GPA scores, and you can see here that this is our histogram, and so we've simply drawn a curve to represent the highs and lows in our data. So you can see then that 3.0 is the middle of this. We have 2 to 4, so 3.0 is the middle. So our black students are scoring slightly to the right of the middle, so it's not symmetrical. And most of them are scoring, it looks like about a 3.13. Okay, but when we look at white students on the same spread here, we see that right here is the 3.0, and actually the peak of our curve is over here closer to 3.5. Okay, so when we look at these two curves, we can see that they're not identical, and especially the white students. So this gives us a little bit more information on the characteristics here of the mean, median, and mode. So let's look at this chart here. Imagine the test we gave. Imagine that we give a test to students, and most students do well, but a few do very poorly. If we were to take a look at the mean, median, and mode of this type, we'd see the scores laid out in different format. They would be skewed, what we call negatively skewed. Okay. So what we're saying here is this is the typical bell curve, but let's say that we gave a test to 20 students and most of the students scored a 90 on the test. Our median score, our middle score was maybe an 80, but our average score was 77. So what happens here is that we have a negatively skewed distribution. And what it's telling us is that when we look at the mode and see that most students scored a 90, if we were to look at just the mode and describe the central tendency as most being around a 90, then we can see that in general most students understood the material. What this really highlights, though, when we compare this to the median of 78.5, is that there were a few students, if our mode is 90 and our median is 88 or whatever we said, 87.5, but our mean is 78.5, then the few students who scored low really scored low, and they were compensated by these high scores. Okay, so when we look at data, one way that we're going to see this happen is when we look at data in the aggregate, we're going to see one thing, but when we break data down and disaggregate it into different things, we're going to find those extremely high and extremely low scores. Okay, so that's going to help us understand this idea of central tendency when we're looking at student data. We could say that all students in our school, of all the students, 80% of them are passing proficiently on the state testing. That's probably the mean that we're looking at. Well, it is the mean. That's how we express it, as the mean. But let's break that down and take a different look at it, okay? And we're going to deal with that later on in our course. But you get the basic idea then here that by looking at these other two types of averages, the median and the mode, we do get a better picture of what we mean and how things are distributed. So relationships among the means, how can we use the mean, median, and mode to impact what we're trying to do? Consider the perspective of the person. If the student in this example, where we said we had a mode of 90, if the students were to say their average score as a class, they may choose the mode and say, hey, the mode in our class was 90. Everybody is doing really well, okay? And that would not be a lie, but that's what they would use because they wanted to show that everybody's doing well. The teacher, on the other hand, may express the actual mean of 78.5 in an attempt to motivate those who are not doing so well, okay? So depending on what your goal is, and your ethics of how you're going to get to that goal, you would express average in the various ways. One last thing to consider too is, and you hear this in the news all the time, and this is when we talk about median household incomes and median house price for houses sold during a certain month. Notice, you may not have ever noticed, this is always expressed in the median. It is not the average. And typically the reason for that is because these numbers can be very easily skewed. Take homes, for instance. If a median home in Tulsa costs $150,000, there are homes in Tulsa that sell for $5, $10, or more $1 million. And so a home that sells for $150,000 compared to a home that sells for $5 million, it would take 50 $150,000 homes to get to that one $5 million home. So if we simply went by average, then it may look like the typical home is out of range for many people if we simply went by the mean. But if we express it in the median, what's the middle number? Then it appeals to more people. Okay, and so that's one of the reasons that homes sold and household incomes are expressed in median and not mean, because those are typically skewed negatively because of high incomes or a few high houses sold that really skew the data. Think of the average worker who makes, a beginning year teacher makes $36,000. An executive at a private company may make $300,000, $350,000. Well, it's going to take 10 teachers to equal that one salary. And so the average is going to be skewed. And so that's why it's expressed in median. Okay. So your assignment, we're going to use the same data we had in Module 0. And you're going to look at height, you're going to look at pulse rate, and you're going to look at credit hours. And so what you are going to do is you're going to find the mean, median, and mode for the height, for the pulse, and for the credit hours. Now this is just giving you some basic practice, okay? There's really nothing we're going to draw from this, but you'll get the practice, okay? So then you're going to analyze and interpret the data for each. So once you figure the mean, median, and mode and height, you're going to analyze the data, explain what the data are saying, referencing the mean, median, and mode. Typically these are going to be pretty straightforward because we're dealing with something as innocuous as height. Height really doesn't have an indication of your achievement in school. So it's going to be pretty innocuous. And then you're going to interpret the data to tell us the so what of the height. Okay? And again, there's going to be nothing earth-shattering here. It's just to get you into this practice of analyzing the data once you have them, and then interpreting those data and telling us the so what. Okay? So, like I said, this will be nothing that's earth-shattering. It's pretty straightforward. It can easily be done overlapping Module 1. This analyzation and interpretation will change in the future and become much more significant. So this will be pretty straightforward and easy for you. I look forward to any questions you may have, so feel free to reach out.